Aluminium has the atomic number 13 and consists of 13 electrons arranged in 3 orbits around a positively charged nucleus. The 3 outer electrons give it a valence of +3. When aluminium changes from molten to solid state, it forms a crystalline structure known as a lattice. This structure is typical in metals like copper, silver, and gold. Aluminium atoms are arranged in a face-centered cubic structure, with atoms positioned at the cube's corners and at the center of each face, optimizing its ductility. The density of aluminium, as per theoretical values, ranges from 2697 to 2699 kg/3. It remains relatively stable even when alloyed, except for lithium alloys, which can reduce density significantly. Aluminium's electrical conductivity is about 63.8% of the international annealed copper standard, and its mass conductivity is over twice as much as that of copper. Aluminium and its alloys are very slightly paramagnetic. The magnetic susceptibility is not sensitive to strain hardening, but varies slightly with temperature. The low magnetic characteristic of aluminium is of value in military ship structures. It is also used to advantage in electronic equipment in the form of finned extruded profiles. The mass thermal conductivity of 99.99% pure aluminium is twice that of copper. The thermal conductivity is reduced slightly by the addition of alloying elements. The combined properties of high thermal conductivity, low weight, and good formability make aluminium an obvious choice for use in heat exchangers, car radiators, and cooking utensils. While in the cast form, it is extensively used for engine cylinder heads. The emissivity of aluminium is low, 10% of a black body, making it an effective reflective insulating medium. It reflects 75% of light and 90% of heat radiation. Aluminium exhibits high corrosion resistance due to a protective oxide layer that forms naturally on its surface, which is beneficial in various environments. The recommended values for the coefficient of thermal expansion, CTE, are as follows. These values for annealed 99.99% aluminum. The CTE is thought to be values for metal of commercial purity, lie within the experimental error of those of the pure metal. The melting point of aluminium is sensitive to purity. E.g., for 99.99% pure aluminium at atmospheric pressure, it is 660 C, but this reduces to 635 C for 99.5% commercial pure aluminium. The addition of alloying elements reduces this still further down to 580 C for aluminium alloy with Mg content of 5%. In summary, the diverse properties of aluminium, from its lightweight nature to its high strength and conductivity, make it a crucial material in aircraft construction and many other industries. Thank you for watching. Remember to like, comment, and subscribe.